Welcome to my channel. The subject we are going to discuss today are relations. Given a set X, we see E is element and A, B, B, C, C, D, D, A are already ordered things. So, R relation R is defined as these are the ordered pairs of X. R is subset of set which is a subset of these ordered pairs such that X, Y belong to X set X. What is the definition for relation? When we say relation, there are many kinds of relations. What basically is a relation? Relation can be, let's say, greater than one relation, less than is one relation, equal to one relation, or equal, anything which relates to objects. Right. So, this relation can be from set X, the elements of set X itself, like this, or it can be between, let us say, this X, this Y, A, B, C, D, 1, 2, 3, 4, right? The relation can be between these two, the elements of two sets, or for that matter, it can be relation between any number of sets. So, what we call this is unary relation. If there are two sets involved, then we call this binary relation. If you have three sets, you call it trinary relation. Okay, so we'll come to that later, but this statement, this mathematical statement, X, Y belonging to R should be read as X, this X is related to X is R related. meaning this is the R function. X is through R the relation related to Y. That's how we read it. X related to Y. It can be written as X R Y. X relation Y. This is called infix relation. Why? Because this R is in between X and Y. So this is called infix relation. Sometimes this is represented as 1xy, xy, like that also we can. This will be then prefix. Relation is mentioned in the beginning, then the variables are mentioned after. Prefix, postfix also can be there. Meaning, after the elements, you mention the relation. So, then yeah, when it comes, we will come to properties of relations. When we come to properties of relations, let's say we have a simple relation X or Y. That is, the element X is related to Y in relation R. So, if X or Y is true, then it is not necessary that Y relation are true. This may not hold. Let's say there is one what do you call division function, the division relation. Let's say 3 divides 9, but the reverse is not, 9 does not divide 3. Meaning the reverse may not be true. So, what kind of relations we have? These are the relations are very important in I mean properties of relation. First property is reflexive. Reflexive is if X belongs to X, X belongs to X, then X belongs to X, then X relation X, meaning reflective. Basically, let us say greater than function. Greater than function is not reflective. Example, greater than function is not reflexive because X is equal to X, right? Not X is not greater than X. That is the reflexive property. in the sense greater than, less than, these are not reflexive. Equal, whereas equal relation is reflexive. And so that is the first property, reflexive property, wherein the the element should be equal to, if it is equal to itself, x itself, x is equal to x itself, then that is reflexive. If any other condition, any other is not reflexive. Now, so now, fixtures. Next we will come to, of course, the opposite, irreflexive. Irreflexive. Irreflexive is naturally the opposite of x relation x. That is, it is not x or x, not x or x. X. Okay. If you take, let us say, example of equal. Equal is irreflexive. Why? Because x is equal to x. So the opposite, f is not equal to not x. It is not. So this is irreflexive. Whereas greater than, let us say greater than, sorry, greater than, x is not greater than x. X is in fact is equal to x. So x is not being greater than x. This is irreflexive. Right? So first reflexive, second property is irreflexive. Then comes the important property, symmetric. Symmetric. Then if for all x, okay, for all x, if x or y, if x or y, then y or x holds true. Meaning, let us say, the symmetric function is for all x, x is related to y should also be related to x. Only then it is symmetric. Okay. So, yeah, we will be using this function a lot. Antisymmetric. For all y, for all x, y belongs to x. These are all, mind you, all to unary relation. For all x, y belonging to x, if x or y, there is a relation from the order of relation is also very important here. This is a relation from X to Y. Okay, this is what do you call? This is called departure. This is called destination. So if X is related to Y is related to X, then Y equal to X. Or rather, X equal to X equal to, meaning that we are the same. That is antisymmetry. Fine. Asymmetric. We have now asymmetric. It is very opposite of this thing. For all y belongs to X if X is related to Y, then not Y or Y related to X. Meaning X is related to Y, but Y is not related to X. As we have seen in the very beginning, that 3 divides 9. 9 does not divide 3. So X relation to Y, if there is relation R exists between X to Y, it is not necessary that there should be a relation existing from Y to X. Okay, so this is a similar case for all y belonging to X. If X related to Y, then not Y related to X. There is no relation from Y to X. Y to X, there is no relation. X to Y, there is relation. But then that is asymmetric. Now, transitive. Transitive property. For all X, Y belonging to X, if X equal to Y, then X or Y or Y or X, meaning the property transmits. If X is related to Y, then Y is related to X. These two can be true. These two can be true. Here it is not true, so it is asymmetric. In the transitive, for all X, Y belonging to X, if X equal to Y, then if X is related to Y, Y is related to X. That is, it transmits its property with the relation to others. Now, what is the example? Let us say, let us say we have the set of real integers, the set of sorry, real number, set of integers. We have the integers is and we have natural numbers also. So you can say all, let's say, if all integers, integers include minus infinity to plus infinity, right? All the three numbers. So these integers are real numbers, right? Real. So, and then this is natural. N is natural. Set of n z. This is natural. So this property is transmitted in the sense all the integers which consist of natural numbers as well as negative integers. So if this is real number, then this must be real. That is the answer. Now coming to the next property,